In this demonstration, I'll show you an example on how to integrate by parts for definite integrals. What you'll need to know, and it's best to memorize, is the following. And in addition to that, when it comes to integrating by parts for definite integrals, you'll also need to know this. So let's jump right in with an example. In this example, they're asking us to find the integral for the function x to the power of 7 times ln x dx between the intervals 1 and 2. Now, as discussed in the video pertaining to integration by parts, you'll need to know how to assign your u and dv. And assigning your u is the most important part. The way you determine what to assign your u is you follow this acronym, LIATE, which tells you the priority in which you should set your u. For example, inverse trig gets more priority than algebra. Trigonometry gets less priority than algebra and less priority than the rest. So, in our case, we have a product, and this right here represents algebra, and this right here represents logarithms. And that said, your u will take on ln x, and your dv will take on x to the power of 7 dx. Now for the top, you'll find the derivative, and for the bottom, you'll integrate. So let's go ahead and do this. What is the derivative of ln x? The derivative of ln x is 1 over x times the derivative of x. The derivative of x is 1. So your final answer is du is equal to 1 over x dx. Now we're going to integrate the bottom, and if we integrate the bottom, we end up with v is equal to x to the power of 8 over 8. This increases by 1, and then you take that number and you place it below. So now that we have those two important features, we can now plug them into here. So let's do that. U times v, u was ln x, and v was x to the power of 8 over 8. So times x to the power of 8 over 8. Now one thing that you need to keep in mind according to this is that at this point, here's where it differs from indefinite integrals. Here, you will evaluate this part of the function at 2 and 1, and then you're going to subtract and evaluate this from 1 and 2, and recall it was v times du, so our v was x to the power of 8 over 8 times du, which was 1 over x dx, and this cancels out with this. And so what we're going to do here is evaluate what this is and then subtract it by what that is. So what I'm going to do is find the integral of that, and the integral of x to the power of 7 over 8 gives you x to the power of 8 over 64. So just keep that in mind. We're going to evaluate this, x to the power of 8 over 64, between 2 and 1, and similarly this between 2 and 1. So let's start off with that, and we're going to use our calculator. Follow carefully. Ln 2 times 2 to the power of 8 divided by 8, 22.18, and we're going to do the same thing and evaluate this at 1 and subtract it from this number. So just keep that number in mind. You can write it down. Minus, big bracket, ln at 1, 1 to the power of 8 is 1, divided by 8, and the answer we get is 22.1. So all of this becomes approximately 22.1. And now you're going to do the same thing for this. We'll start off with 2. 2 to the power of 8 divided by 64 gives us 4. Now just keep that number in mind. We're going to do the same thing and at 1. So we're going to subtract this by what we get when we evaluate this at 1. Minus, big bracket, 1 to the power of 8 is 1 over 64. We have 1 over 64. And we're going to take 22.1 and subtract it by this number. 22.1 minus the answer that we just got gives us a total area of 18.11. So there you have it. That is how to integrate by parts for definite integrals. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We are an online service for students seeking free homework help. See you soon.